Solving applications of quadratic inequalities follows the same process as quadratic inequalities. Example 1, a company's profits are given by the equation P equals negative x squared plus 740x minus 28,000, where x is the number of items sold. For which values of x does the company make a profit? So if the company is making a profit, that means that the profit is positive, or we're looking for the values when p is greater than 0. So for p to be greater than 0, this algebraic phrase negative x squared plus 740x minus 28,000 must be greater than 0. So that's the quadratic inequality that we're going to solve. Negative x squared plus 740x minus 28,000 is greater than 0. Now to solve this quadratic inequality, we need all terms on one side, which we have, and then we'll factor this equation. One thing that would make this easier to factor is if we take out a negative 1 from each of the terms. So if we divide by negative 1, then we would have negative 1 times x squared minus 740x plus 28,000. So taking out a negative 1 just changes the signs of our inequality. And now let's factor this quadratic equation. So we're looking for two numbers that multiply to 28,000 but that add to negative 740. And those, you could list through many possibilities of numbers that multiply to 28,000. It has many factors, but since I see this 7 and this 4, that's a hint that perhaps the two factors are 700 and 40. If we check that those do multiply to 28,000, we want them to add to negative 740, so make them both negative. And then our factored form is negative 1 times x squared, just x minus 700 multiplied by x minus 40 greater than 0. Now, just as before with quadratic inequalities, we now solve for the solutions. So we set x minus 700 equal to 0, and we set x minus 40 equal to 0, and solve. So for this first one, add 700 to both sides. One of our solutions is x equals 700. And then add 40 to both sides, and our other solution is x equals 40. And now we'll plot those two numbers on a number line. Okay, and then we choose our test points. So we choose something in the interval before 40. So we could choose 0 as our test point, plug that into the factored form equation. That would be negative 1 times 0 minus 700 times 0 minus 40. We want to know if that's greater than 0. So negative 1 times negative 700 times negative 40. And this will be negative 28,000, which is not greater than 0. So this solution area is not part of our solution set. So now we'll choose a number in between 40 and 700. So we could choose 50, 100, 200, any number in there. I choose 50. And then test that in the factored form equation. So negative 1 times 50 minus 700 times 50 minus 40 greater than 0. That's negative 1 times negative 650 times 10. So that would be 650 times 10, which is indeed greater than 0. So this solution area works for our inequality. Finally, we choose a number to the right of 700, so we could choose 701, we could choose 800, 1000, let's do 800. plugging in 800, we get negative 1 times 800 minus 700, which is 100, times 800 minus 40, which is 760. We want to know if that's greater than 0. And even from here, we can see we have a negative multiplied by a positive multiplied by a positive, so this result is going to be some large negative number, which is not greater than 0. So negative some large number. So therefore, this area is not part of our solution set. So for which values of x does the company make a profit? It's only those values of x between 40 and 700. So written as an interval, that would be 40, 700. Or written as an inequality, we could say that x is between 40 and 700. Example 2, a company's profits are given by the equation P equals 4x squared minus 23x plus 15, where x is the amount in hundreds of dollars that is spent on advertising. For what values of x does the company make a profit? So to make a profit, we need P to be greater than 0, so that means this quadratic equation, 4x squared minus 23x plus 15, needs to be greater than 0. First step is to move everything to one side, which we already have. Second step is to factor. Now to factor this equation, since we have a number other than 1 in front of x squared, we have a 4, we need to use factor by grouping. As an alternative, you could also use the quadratic formula to find the solutions, but I'll show factor by grouping. So the first step of factor by grouping is to multiply the x squared coefficient by the constant term, so 4 times 15 is 60. Then we look for the factors of 60 that add to the middle term, which is negative 23. Those two factors that multiply to 60 and add to negative 23 are negative 20 and negative 3. Okay, second step is to split the middle term, which is negative 23x, into those two numbers that we just found, negative 20 and negative 3. So that would be negative 20x and negative 3x. Then rewrite the rest of the equation. So rewrite 4x squared, rewrite 15. Now we group the terms, first two and last two. We look for a GCF of the first two, which is 4x. If we divide 4x out of those first two terms, we would be left with x minus 5. Now we take out the GCF of these second two terms, which is negative 3. If we take out negative 3, we again get x minus 5. And then the factored form, you can see that we have x minus 5 written twice, so we pull out that grouped term, x minus 5, and then the other factor is the two GCFs, 4x and negative 3, so 4x minus 3. So our factored form inequality is x minus 5 times 4x minus 3 greater than 0. And now we find our solutions. So set x minus 5 equals 0, and set 4x minus 3 equals 0. This first one, add 5 to get x equals 5. Second one, add 3 to get 4x equals 3. And divide by 4 to get x equals 3/4. Plot those on a number line, and now we choose our test points. So something before 3/4, less than 3/4, we could choose 0. And we could plug this into any form of the equation. Choose the factored form. So plugging in 0 to the factored form, we get 0 minus 5 times 4 times 0 is 0 minus 3 greater than 0. That is negative 5 times negative 3, which is 15. Since that's true, this region on the number line is part of our solutions. Now we choose something between 3/4 and 5 to test, so we could choose 1, 2, 3, 4, or any fraction or decimal in between there. Let's choose 1. Plugging into the factored form, we get 1 minus 5. 4 times 1 is 4, minus 3, greater than 0. That's negative 4 times 1, which is negative 4. Since negative 4 is not greater than 0, this solution area is not part of our solutions. Now we choose something to the right of 5, so we could choose 6. In the factored form, that would be 6 minus 5. 4 times 6 is 24. 24 minus 3, greater than 0. So that's 1 times 21, greater than 0, which is 21. Since 21 is greater than 0, this area of solutions does work. So now we write our solution area from the number line. So the solution area is negative infinity up until 3/4 union 5 to infinity. But now if we think about this situation, so we're considering profit. In this equation, an X is the amount in hundreds of dollars spent on advertising. Some of these solution points do not work. For example, we can't spend a negative amount of money on advertising. We could spend nothing on advertising, so we could spend 0 on advertising, but we couldn't spend negative $10, $100. So we need to adjust this solution. And in particular, we need to adjust this part here. So we could spend 3/4 of $100, that would be $75, but we need this first interval instead to start at 0. So it'd be 0 to 3/4 union 5 to infinity. And that's just because it doesn't make sense to spend negative dollars on advertising. So we replace this first solution with 0 to 3/4 union 5 to infinity. That's an additional step for these application problems where you actually want to think about what values make sense for the problem that you're working on.